All right, so I'm looking at number 1A on the review, and it was the problem f of x equals x cubed plus 5x squared plus 5x minus 3, and I wanted you to completely factor it. And so I wanted to, in order to figure out what the factors were, I looked at the constant term, which was -3. So I knew the factors that I should try and consider are plus or minus 1 and plus or minus 3. And I could use the remainder theorem to see if any of those were factors. So I plugged in -1, and I got that what it equaled was not 0. So I knew it wasn't a factor. And then I plugged in -3, and I got that it was equal to 0, so I knew x plus 3 was a factor. Once I know that it's a factor, I can use synthetic division to factor it. So if you want to pause right now, you can, but I'm going to pull up a new screen if you're ready to move on. So I used synthetic division with c being -3 because I knew x plus 3 was the factor. And I got that our original polynomial here factored to be x plus 3 times x squared plus 2x minus 1 based on the coefficients that I got from the synthetic division. Now I look at this trinomial just to double check that it's not factorable, and it's not. There's no two numbers that multiply to be -1 and add to be 2. So since that trinomial isn't factored, this is our original polynomial completely factored in factored form. So we're done. Now I want to go back to a problem from our last class before the review day, and it was under the section factor theorem and synthetic division. I think that in my B block class I got to go over it, but I didn't get to go over it in my G block, and I think just having it in video form will be helpful to both classes. So if you want to get out your notes, you want to pause and get out your notes from the last class, that might be helpful right now. So that problem was saying that x equals 1 and x equals -1 were roots of that polynomial f of x, this polynomial right here, and it wanted you to use synthetic division twice to show that they were roots. So you could start with either one. I started with c equaling -1. When I do the synthetic division with c equal to -1, I get these as my coefficients. So that means my original polynomial, f of x, factors to be x plus 1 times this sucker based off the coefficients that I got from the synthetic division. Now, because I know 1 is also a factor of the original polynomial, I can just take this polynomial and apply synthetic division to it. When I do that, I get these as my coefficients. So that means my original polynomial, f of x, factors to be x plus 1, the first time I did synthetic division, times x minus 1, and then based on these coefficients, I know this is my remaining factor, x squared minus x minus 6. Once I have it to a quadratic, which I do, x squared minus x minus 6, my last factor to a quadratic, I could just check to see if I can factor it, and I can. I know -3 times 2 equals -6 and adds to be -1. So in fully factored form, I get x plus 1 times x minus 1 times x minus 3 times x plus 2. And if the directions had said to graph it, I would know to do that now, because originally it was in standard form, so I knew what the end behavior was. And then once I got it to factored form, I would be able to plot all the x-intercepts. And every single one has a multiplicity of, every single factor has a multiplicity of 1, so it would be pass through, pass through, pass through, pass through. Again, the directions didn't say you needed to graph it, but you have all the tools in your toolbox to graph it. Okay, these are the first two that I'm starting with. If I get any more emails about other problems you would like me to do, I'll be happy to do them. Keep up the good work studying. Woohoo! We love polynomials.